Hello everyone and welcome. I'm going to be sharing with you a solution I came up with recently for storing hardware in my workshop in the drawers of my tool chest using a 3D printer. We're going to talk through the problem, which is I think a very common and basic problem that many of us have who have been working on things for a number of years. We're going to talk about the solution and what were my priorities, what was important to me in finding a solution for storing my hardware. And then I'm going to give you a couple of tips for printing these parts. Nothing too complicated. These are easy parts to print. Just want to give you a few pieces of information so that you'll have a better chance of being successful when you print them. And finally, uh, we'll install the parts into my tool chest drawers. Now, if you like these parts or you like the concept and you want to download and print these for yourself, I've made them available for free download over at Thingiverse. And there is a link in the description over to Thingiverse and specifically to my project. Uh, if you try them out, please leave me a comment and just let me know whether you like them or not and why. All right, let's get on with it.
Here we have the problem. This drawer represents roughly the last 6 years of my life in terms of repairing a bunch of different things in my shop, in my vehicles, and the hardware that's left over after those repairs. I go to McMaster Car, I go to Amazon, um, I go to some local shops, and usually you can't just buy one bolt or one nut. You have to buy a package. And yeah, so this is now what's left over. I have a number of things from projects I've worked on. These springs are from the chuck on my Victor lathe, and they were missing in a couple of locations. These ball bearings came out of my Dodge diesel truck. I recently resealed the fuel injection pump, and these ball bearings there's only two of them in the whole thing, and you can see I have quite a few more. Um, Set screws. I got a bunch of set screws over here. I use an Aloris CA tool holder on that Victor lathe, and I bought a bunch of tool holders that were missing hardware. I got a good deal on them, but I just needed to add hardware. So I ended up having again to buy things in lots of 20, 50, 100. Yeah, and then I have stainless steel, I have metric, I have SAE, black finish, a bunch of stuff under here. So I just want to get it more organized. Every time I go into this drawer to look for something, it's frustrating, and I have to usually pull out 3/4 of the stuff in this drawer just to find what I'm looking for, or find out that I don't have what I'm looking for. So I wanted to make it easier on myself to figure out what hardware I have and find it when I need it. So let's see how we're going to do this.
Now that you've seen how things are in my tool chest, let's talk about the solution. Now, one of the prime goals is to free up the drawer that the hardware is currently sitting in, which is 6.5 inches deep. I want to move it to the shallowest drawer or drawers, which are only 2.5 inches deep in my tool chest. So that sets the maximum in the Z direction. This system can only be 2.5 inches high. Uh, and I also wanted to create a system that would work regardless of the drawer size, regardless of whether it's 10 inches wide or 20 inches wide, and whether it's 10 inches deep or 20 inches deep in the Y direction. I wanted to create a system that could fit into any size tool chest drawer. Uh, The bins, or the storage containers, which will hold the hardware, wanted them to be movable. So, I didn't want them to be stuck in one spot only. And I wanted a variety of sizes so that I could match the size and the volume of the hardware to a specific sized container and not have a bunch of empty space in a container, or not have it overflowing with parts either. Uh, and labeling is important to me. I wanted to be able to put labels on the containers so that I could quickly glance and see what the size of the hardware would be in each of the containers. Uh, I think the last thing was that I wanted it to be stable. Since we're going to be opening and closing drawers, there's a tendency for things to move around. So I wanted to create a system that would have an anchor to keep things from shifting around. All right, let's take a look at the actual system that I've come up with. It's very simple. It consists of two components. We've got these grid pieces here, which are going to occupy the bottom of the drawer. And then we have these storage containers. Now these grids are 6 inches by 6 inches and divided into 4 parts. So each part is an inch and a half wide. And the idea is that you can string enough of these together to cover the bottom of your tool drawer. And you string them together because they have hooks on one side and then a female slot on the other side to connect them together. So you can just slip the hook into the groove, put it on the bottom of your tool chest, and they stay connected and won't move independently. Now you're going to want to fill up the entire bottom of your tool chest drawer with this grid material from wall to wall so that it can't move around. Now if your drawer is not a multiple of 6 inches, let's say it's 20 inches instead of 18 inches, it's easy enough to either use a hot knife to cut one of these down, or you can just go into your slicer program and trim it down so that it only prints a piece that's 2 inches wide to make up the extra 2 inches if you have that 20-inch drawer. Okay, and then here we have the containers. Again, simple. They've got a little handle for your thumbs so you can pick it up more easily when they're all in there together, pressing up against one another. There's a little 1/4-inch shelf for a label. And they come in various sizes: 1.5 by 1.5, 1.5 by 3, by 4.5, and there's also some that have a 3-inch dimension, so 3 by 3 and 3 by 4.5. There's eight containers total, and these have a square foot on them. So the 1 by 1.5 by 1.5 has a single foot. The 1.5 by 3 has 2 feet, and so on. And these feet sit down in the grid. And you can connect these over the grid where it overlaps, where the hook and the groove are. There's no constraints on where you can place these containers. You can stick them in any direction, but you probably want them to be all lined up in facing in a similar direction. And once they're all in place, again, it has these handles, so you can pick them easily up out of their position, and then they fall right back into place. And with this grid, everything's going to stay steady. The containers aren't going to fall over, your parts aren't going to spill out. I'm trying to make this as low tech as possible. So this is not going to help you charge your selfie stick, and this is not going to tell you how many steps you walk today, but it is going to keep your hardware from moving around in the drawer. And that's what's important.
Printing the base grid is pretty straightforward. You just plop it down in your slicer program. And there's no need for supports. I actually tried printing with supports for these little cutouts here. Oops, right here. There, right there. That mate with this piece here. But what I found was when I used supports, it was impossible to cut out. So what we'll have to do, and I'll show you in a moment, is after printing, you'll just have to trim these little areas out. A couple of little strands will appear in there that interfere with allowing for a good connection with the neighboring grid piece. So we just need to trim that out with an X-Acto knife. So anyway, just put it in your slicer and go. We're ready now to start printing the base grid. For this project, I'm going to be using PETG. Uh, Another obvious option would be PLA, but I find that it's too brittle and breaks too easily. We get into something more exotic like APS or nylon or polycarbonate, but then it becomes a little bit more tricky to print, especially without an enclosure. So I'm using Overture PETG. Find it's a good balance of cost and benefit. A box from Amazon's $19. I also like Prusa's filaments, but their PETG is $30, and then you also have to ship it over from Europe. While their shipping costs are extremely competitive, it's still just the base price, $11 cheaper for Overture, and it does a really good job. So that's the direction I'm going in. All right, well, this is going to take about an hour and 20 minutes to print, and once it's done, we'll come back and I'll show you just how to clean up the grid piece so it's easier to install. See you in a bit. One other thing I'll mention here, if you haven't cleaned your printing surface in a while, do it before you start making this print. You can see now as we're starting to print that it covers the majority of the tray, yet the actual print itself only covers maybe 5 or 10% of the actual tray, and it could be prone to lifting since you don't have a big solid footprint. I mentioned earlier in the video that I was going to need to go back and trim some of the grid off to make it work better, and specifically what I need to trim off is the female side of the hook and latch system that helps nest these grids together. So you can see in here I've got some loose stranglers that appear because I printed this without supports. However, the grid was printed upside down compared to its current orientation. But I found that if I printed it with supports, it was just a much bigger pain to try to get this cleaned up. So anyway, that's what you need to trim out. There's going to be 4 of them, all the female ones. The male ones are going to be just fine. So you don't really need to do anything to those. It's going to be difficult to catch this well on film, so I'm still going to go through the motions here really quick just so you can get a sense for what I'm doing. I'm just taking an X-Acto knife and trimming out these little strings that popped up in each of these grooves. So there's some there, and then there may or may not be some in here. So here's another one. I just kind of cut them off both ends. And the reason we're doing this is so that when the hook overlaps with this,
that it fits in cleanly and doesn't interfere at all. And that makes the grid sit flat on the bottom of the tool drawer. All right, that should do it. And then to test it, I'm just going to take a second piece of grid and slide it down there and just make sure it feels like it's seating correctly, and that looks pretty good. And let's turn it to the other side, try that one. Yeah, again, that fits pretty good. Now, it's not gonna click into place or anything. This is all just held in by gravity. But when you have a bunch of bins on here that have a bunch of hardware in them, all this is gonna get weighted down and nothing's gonna move. You can see how easy it is to install these pieces into the bottom of your workbench. Now, I've made sizes for the very end that are smaller than the standard size piece. That's because my drawers work out to a non size that doesn't quite line up with 6 inches. There you go. And there we go. Once again, using my handy Prusa Mini Plus 3D printer. And I'm going to do some 1.5 by 3 bins. And there's no real trick to doing these. You don't need to use any kind of supports or anything. I just hit go and let it print. And when it's done, with all things PETG, you need to let it cool for just a moment before it will release from the tray. And that's about it. All right, well, it looks like we're done here. Let's pop this off. Take a quick look underneath. Make sure the first layer adhered. Got a little junk here. I'm not sure where that comes from. Yeah, but overall, it looks good. We're going to use it. Before we start installing the bins into the drawer, I want to take a moment to clean up some of these bins. The blue PETG that I've been using leaves an awful lot of strings on the print, and you can't work with it like that. You got to clean it out. The red that I've been using prints beautifully. I mean, almost no strings, maybe sometime one up here at the very tip. And I'm sure there's settings in the Slicer program that can help me deal with this, but I haven't figured that out yet. So one way to attack this stuff is with fire. So I'm just going to use my torch here. Turn it down a little bit, and so again, here's what it looks like now, and just quickly kiss the flame over the strings, and it melts them, burns them up. And don't hold it there too long because it will melt, this plastic. But here we go. Now you can see it's much better. A little more on the handle. Okay. Much better.
Let's wrap up the discussion on the bins by going over the few details that I designed into them, and we'll just also talk about the sizes again really quick. So this one here is a 3-inch by 1.5-inch bin. I put on each one a thumb handle, so you can pick it up like this. It's easier than trying to grab it from the edges, especially when it's nestled up against its neighboring containers. I put a lip here, and you can use a label maker and 1/4-inch label to put the information on there, kind of like on this one. And again, it has the squares on the bottom so that it sinks into the grid and stays put while opening and closing the drawer, or during any other time. So that's about it. We've got three of these that are 1.5 by 1.5. We have one that has single compartment, one with 2 compartments, one with 4 compartments. Then we've got the 3 by 1.5, 1.5 by 3, 1.5 by 4.5, 3 by 3, and 4.5 by 3. So hopefully that'll give you enough options to use with your hardware. For the last 2 weeks, I've been printing hardware bins, and I finally got all of my hardware sorted and moved up into the shallow drawer. Now here's the drawer that everything was in before, the 6.5-inch deep drawer. There's still some stuff in here. There's some plastic cases of hardware, which I think it's just best to leave them in those plastic cases, and some dowels and some hinges, but basically everything in this drawer is not something that I would want to put into one of these bins anyway. So let's take a look and see how it turned out. Yeah, I'm pretty excited. I think it looks really nice and it works really well. I'm really pleased. One thing that I'll share with you that I didn't mention in the previous parts of this video is that I shored up, I reinforced the thumb handle on the bins that are 3 by 3 and 4.5 by 3. And I found that over time, when I was picking these up and putting them down, that I actually broke the tab on a couple of these. So I reinforced that tab or that thumb handle so that it could handle a heavier load.
The last thing I'd like to discuss is labels. I like to use labels because I like to know where things are. Sure, I can see what's in the bin, but having a label there sure helps me out, especially when it comes down to thread pitch and length. As you saw earlier in the video, I made a little shelf on top of each bin so that you could put on a 1/4-inch tall label. That's about the smallest label I think you can get. And I did it with this Brother. It's a Brother P-Touch D220. You know, nothing magic about it. I just went on Amazon and looked for a label maker, and that one was 30 bucks on sale. So that's the one I chose. As far as the label material, I went with white text on a clear background. I chose that just because then the color of the bin shows through, and I think it looks attractive. The white on red or white on blue, white on black, it all looks pretty sharp. With that, I think that'll wrap up this video. Thank you so much for coming by to check it out. If you're interested in downloading these files, look down in the description for the link over to Thingiverse, and it'll take you there where you can download them and try them, print them out. Okay, so long for now.